Welcome. The title of today's notes worksheet is Difference Quotient. This expression that we will be working with over the course of this lesson has quite a bit of significance in calculus. Unfortunately, we don't have the background to kind of see all of that context, but I will try to give you some background with this nonetheless, and we'll kind of start that out. But your responsibilities primarily are just the manipulation of this expression for any function that I give you. So let's at least try to set up a little bit in the meantime though, so you can at least see where this expression comes from rather than me just giving it to you and saying go for it. So here's what I'm thinking. It says on your paper, the investigation, use the given diagram and labels to determine the slope of the line. I will be drawing what is called a secant line, passing through the 2 points on the graph of the function. So how about this, everyone? If you get an opportunity, can you just go ahead and give me just a coordinate plane, something like this. I'm going to go pretty top-heavy up in the first quadrant there. And I guess draw any graph you'd like that would pass the vertical line test. So maybe something like this is fine. It really does not matter. So anything that passes the vertical line test. And so what we're going to do is just pick a couple points on the graph of the function. I'm just going to pick one right here, and I'm going to pick one right here. And I am going to label them in a very, very, very particular way. Now it should be noted, a couple lessons down the line, we will come back and draw a graph, a diagram very similar to this right here, but sort of do it in a little easier fashion, I guess is the best way to describe it. So right now it's just to get the difference quotient, but when we really see it and we try to do some good higher level math with it, it'll be a little easier than what you see here. Okay, here's what I'm going to ask you to do. From that first point, let's go ahead and just sort of draw a little dotted line coming down. And then I'm going to try to express the input and output, basically, the horizontal and the vertical. And I guess going from 0 to here is the x. So as a matter of fact, let's go ahead and just label that x right in there. Maybe something like this, just so we know it's all the way from there to there. There's your x. Hopefully that works. Okay. And then if you don't mind, let's attach this just kind of to the y-axis, something like that, input and output. And so this would be x from here to here. And as a result, I hope you would all agree, this would be f of x. This would be the y value. So something like that. Again, not truly important, but I think I'm going to label it that way. And everyone, when you get an opportunity, if you can, please, label it as an ordered pair. X and f of x. Okay. So first one, really not too bad, I hope. Next one, everyone, is this. Give me that piece going down to that axis. And what we're going to look at here is really the horizontal distance from the first point to the second point. And this is the part that has a lot of significance in calculus, as that second point actually becomes pretty dynamic. It's going to move. And so what you're going to define this as is the horizontal distance between here and here. And that, as a matter of fact, is what is called h. So if you can go ahead and throw in an h right there for me, that would be great. And then when you get a chance, we'll come back to this momentarily, but let's go ahead and just get that going to this piece right here. So I guess I would ask you this. What would be the input and output? What would be your ordered pair, so to speak, if I had you label that? And so think about it. The input is the horizontal. So everybody, how far is it from the origin to that second point horizontally? And then as a result, there's your input. What would then be the output? Well, I'm hoping you would see that I've gone x units from here to here and h units from here to here. And so as a result, it seems to me that that's x plus h. And if that's the input, then the output very simply is the function value at x plus h. Input, output. Fantastic. So as a result, just kind of putting this piece together, I guess this would be from here to here. This would be f of x plus h. Okay, it's looking good. All right, we have 2 points. It's time to go ahead and draw a line right on through them. And I'm going to do this the best I can here, which, oh goodness, not great. Hopefully you draw straighter lines than me. But it should look something like that, and it's a line that goes through those 2 points. And as you can see, the line would have a slope. And I would ask you this. If I asked you to calculate the slope of the line, you would do rise over run, you would do y2 minus y1 minus x2 minus x1. Think about that for a second. What would that look like if I asked you to do slope? So once again, y2 minus y1 over x2 minus x1. Well, you ready? Let's see. Here's what I did. y2 minus y1, right? This minus this, and then over x2 minus x1. And so it's this minus this. And what do you notice, of course? As we're going to go ahead and simplify momentarily here, numerator I can't touch. It is what it is. Function value at x plus h minus the function value at x. And what about that denominator, guys? X plus h minus x. Algebraically, what happens? Those x's disappear. And as a result, you end up getting this expression, which again, if we're going to take a look at those going on to Pre-Calc 2, we'll see a lot of this. And get, again, a little more background with this and where this comes into play. For right now, we're just going to work with it algebraically. But that, everybody, is your difference quotient. So let me just read what we have on the page here, and then we'll go ahead and it looks like try 4 examples with this, see if we can put it together. So it says the slope of the secant line that you just derived is called the difference quotient. It is an important expression used in calculus as a means of understanding the rate at which a function changes. It is defined as, and let's put it down there once and for all, so f of x plus h minus f of x, and all of that is over h. And that looks great. And, you know, when we talk about the rate at which a function changes, and again, we're going to get into this in a couple lessons in the near future, it's slope. Rate of change is always slope. And so when I asked for the slope of this particular line right here, I'm asking for how the function changes from here to here. Okay, very good. So let's go ahead and utilize that difference quotient as best as possible. Again, your responsibilities are basically evaluating the difference quotient for any function that I give you. So the easiest thing to do is start out with a relatively simple family of functions, because the expression is going to speak for itself. But I'm going to go linear family first, then move on to a couple quadratics, and then let's hit a rational if we can and see if we can pull it off. So just because I need my board right here, I know you have it on your page already, but let me just be clear so I have something to reference. There is our difference quotient right there. F of x plus h minus f of x all over h. So let's think about this for just a second. I guess I would break this up into 3 parts. Top left, top right, and then just the bottom there is obviously just h. So let's see if we can interpret the top left first. And again, notation, it's the key. If we know how to work with functions, this hopefully won't be too bad. This basically says take your function and replace all of the x's with x plus h. X plus h is the input to the function. So let's go to our function for just a second, and it says negative 5x plus 3. What that really means is you take your input, you multiply it by negative 5, and you add 3. This basically says you start out with an input of x plus h. So here's what I'm going to do. I'm going to perform these function rules on this input right here on x plus h. So here's how the top left would work. So I'm supposed to take my input and multiply it by negative 5. So there is my input, everybody. It is x plus h. So I take my input, multiply it by negative 5, and I add 3. Good. Now again, just a couple different ways to sort of think about this. I like thinking of it this way, is just take your function, replace all of the x's with x plus h. And that's what I did. I took my function and I replaced that x with x plus h. And that's it. There's the top left. Everybody put a minus. Now, the back side is basically a change of heart almost. I take my function, you know what, let's put x back in. So let's take our function and put x back in. And when I put x back in, it just becomes exactly the way it was defined. There is f of x, guys, just the original function. Notice, by the way, a couple things. And by the way, let me just put this over h first. subtraction. It's the killer algebraically, so just be very careful with it. I do this intuitively, but when I see a minus, whatever is on the back end, I put in parentheses there, and I'd encourage you to do the same. That way you'll know it's minus each term on the back end. Okay, now let's just clean up. So here we go. Let's distribute, remove all parentheses. Negative 5x minus 5h plus 3. Now look, plus 5x and minus 3, and all of that is over h. It's going to get ugly on us for a little bit, but it cleans up really nicely if you've played your cards right. So let's see. Take a look at the numerator specifically. Look at that. I've got a negative 5x and then a plus 5x. So algebraically, guys, those cancel. Slash them. I have a plus 3 and a minus 3. They cancel. And so you can see when I do that, I end up getting negative 5h over h. And if you notice, you can go even further here. The h is a common factor to the numerator and denominator. Again, because separated by multiplication, it can go. And so as a result, that is the difference quotient for this particular function. Now, if you've been kind of paying attention to the lesson thus far, this shouldn't come as a shocker here. Because remember, it says the difference quotient is a way to measure rate of change, or slope. And on a linear function, everybody, well, the slope is constant. The rate of change is constant, I should say. In this case, it's negative 5. The rate of change, no matter what, is negative 5, and that's what comes out in our difference quotient. If this is a measure of rate of change, it shouldn't come as a shock that that's negative 5 right there. Okay, now what happens, though, when we expand it to a function beyond something that's linear? And so that's what we're going to see right here. Okay, well, let's go for it. So, again, evaluate this expression now for this function. Top left, minus, and then the top right, and don't forget all over h. So here's how I'll say it, try to be consistent. This top left basically says take your function and replace all of the x's with x plus h. So here's our function over here. Those are the rules on the inputs. So I'm going to go ahead and take my function and just replace those x's with x plus h. And that's it. X plus h is the input, and I treat it as such. Now everybody, here's my minus. And back end says, you know what? Let's go back. Let's go ahead and take our function and put x back in. And when I put x back in, obviously we just get the original. And that is all over h. Okay, that's good. If you've done that, that's wonderful. Now it's just a matter of cleaning it up and simplifying. So as I said, it's going to get ugly for a little bit, but good things will happen. Just be careful on the front end, everybody. That's the only thing I would see here where we would potentially make an algebraic mistake. Don't forget what x plus h squared really means. I'm going to just do a touch of work off to the side and then erase it. But x plus h squared really means x plus h times x plus h. So careful, it's not just x squared and h squared. We already looked at that. So in this case, it's x squared. Outside gives me an xh. Inside gives me an xh. I get two of them. And then on the back end, I've got h squared. So just be careful on that. When you see this, it is this piece right here. Okay, I'm going to erase it and then put it in play where it's going to make a difference. So here we go. I remove parentheses, and I get x squared, 2xh, h squared, minus 8x, minus 8h, plus the 2. All right, now here's the key. Minus everything here, everyone. So minus x squared, plus the 8x, and minus the 2. And all of that is over h. It looks crazy, doesn't it? But start taking a look at the numerator there, and we can start narrowing this down nicely. Everybody, x squared's 1 positive, 1 negative. Say goodbye. Negative 8x, positive 8x. Slash them, they're gone. 2's 1 positive, 1 negative. They're gone. So notice everything on that back end canceled with something on the front. So let's see what we have left. 2xh, h squared, minus 8h, all over h. Fantastic. Hey everyone, could you go further? Yeah. Just be careful. I can't just cancel out that h and that h, remember, because it's separated by a plus. But look at the numerator, everyone. What's that technique that you would probably use here to make this happen? I'm hoping you would see you would factor out the h. So factor that h out, and as a common factor, can it now cancel out with that on the bottom? Absolutely. And so here we go. Final answer. So the difference quotient for this particular function is exactly that right there. 2x plus h minus 8. So I guess in terms of rate of change or slope, the rate of change is dependent on two things here. It's dependent on x and it's dependent on h. Now when you do take a calc class, or if you ever get to kind of see this in pre-calc 2, there is one thing you do with this h that would make you go a little further. So it is slightly incomplete at this point, but that is the way it is. It's just the algebraic manipulation. That's the objective here. So that's it. That's all you have to do. But you should know that you do a little more with that h and a little more from there. Okay, good. Let's go get these last two. So one more quadratic and then a rational. So I'm going to go ahead and do my difference quotient one more time up here. And then let's see what we want. Same deal, guys. So let's go for it. Let's be consistent. Take your function and replace all the x's with x plus h. And that's all I'm doing. There's the function. Now with the input is x plus h. Big minus, everybody. Careful on the back. Take your function. Just put x back in. All over h. Now, it would be great if you can kind of pause the video and see if you can work this out and then come back and watch my steps and see if they match. I would go ahead and do this. Don't forget order of operations, everybody. Exponent first, then the multiplication. So again, I'm going to do this, just this piece. This is where I would probably see the mistakes. So I'm just going to do this piece and then erase it and then just put it in place. So I would do this, 2, and then we already figured out what x plus h squared is. That's that, right? So now the only difference is I have the 2 out in front, and I would go ahead and probably distribute that in. So I'm hoping just that piece, you would see something like this. Just careful, it's probably the one difference between these two, having the number out in front there. So that's what I'm seeing for that part. Okay, I hope that works. I am going to erase it and then start with this piece right here. I squared x plus h and multiplied it by 2. Okay, so let me get rid, and let's go for it. So that was 2x squared. It was 4xh, 2h squared. Now let's keep going. Minus 6x, minus 6h, minus 1. And then minus 2x squared. How about a plus 6x? And how about a plus 1? And all of that, guys, is over h. Yikes, on top. But let's see what happens. 2x squared, gone. 6x's, gone. 1's, gone. And so now let's see what's left, and let's see if we can work with it even further. So 2h squared minus that, all over h. Okay, looking good. Again, just be careful on canceling things out. It has to be a common factor, and right now I would have to go ahead and take the h out before doing anything with it. So 2h minus 6, and now it's ready to go. The h's cancel. And there it is. I'm going to have to come up here for just a moment and write my final answer, but I'm seeing it as 4x plus 2h and minus 6. Awesome. By now, the hope is it's really clicking, and you're able to kind of knock these out pretty well. Try to challenge you a little bit and give you different families, as I did with letter D. So let's see. And as a matter of fact, you have seen the algebra behind this before. I don't think I put it in quite these terms, but it is. All right, well, let's see. See if you remember it. So f of x equals 1 over x, so rational family. Let's apply the difference quotient. Top left. Okay, so I replace all my x's with x plus h. There it is. Minus. Top right. Go back and put x back in. And all of that's over h. So I don't think it was too long ago where we worked on compound fractions, and we did exactly this problem. In fact, I probably said it does come from a calculus class. So here we go. It just happens to be the difference quotient for the function 1 over x. Okay, well, let's see what we can do. Let's see if we remember how to do this. I like putting that over 1, just me, but you don't have to if you don't want to. And what we did to get rid of the fractions within fractions, kind of cancel out those denominators there, is we multiplied everything by the LCD. So I'm hoping you see that the least common denominator is the x plus h. Here and here, multiplied together. And so if I do anything to this big numerator right here, then I have to do it to the big denominator down there. So this also gets multiplied by the LCD, as we've talked about before. Well, let's see what happens when we do that. Distribute it in once, distribute it in a second time, and distribute it in a third time down below. Okay, here we go. X plus h's would cancel right there. And you get x times 1, which is x. I'm going to put a minus right there, and then I reset, and everybody, this gets now distributed in here. What happens to the x's? 1 on top, 1 on the bottom. They cancel, and you get x plus h times 1. Cool. Now down on the bottom, you just see it's this times this times this. I will tell you, it actually just benefits us to just write them as factors, just like that, because we're going to try to cancel out a few things in just a moment. And so it just sort of looks better like that for right now. No need to distribute this in, I guess is what I'm saying. Okay, let's remove the parentheses and see what happens. I get x minus h. Careful on that. Again, given this problem many times over the years, that's mostly where I would see the mistake. And then x, h, x plus h. Well, what happens, guys? Exactly what we've seen before. Those cancel. And sorry, I'm going to have to come up here, but it looks like I get a negative 1h over x times h times x plus h. And does anything pique your interest on this one? I'm hoping so. I'm hoping you see the h's cancel. So that would cancel with that right there, and I've got my final answer. And there it is. So that is the difference quotient as we've seen before, but now again you've seen it just hopefully in the context of what we've been working on here. All right, short and sweet, guys. Just working algebraically with this new expression. Let me know if you have any questions on it, of course, and try some of these out. But you'll see the linears, quadratics, maybe a cubic, maybe another rational. Should be comfortable with all of them. Hey, thanks for listening, of course, and again, don't hesitate to ask questions.